All right, in math, we use a lot of words, right? I say a lot of words to teach you the concept. You read words, memorize words, and they help you to understand what the concepts are. There are two words we're going to look at today. Today we're going to start this morning with the word, that's kind of cool, the word and. That's the first key word to this lesson, and. And is not a noun. It's a conjunction. Or is the second one. We'll look at that this afternoon. Or. So today we're looking at the words and or. Can somebody tell me what the difference between the words and or are? So I'm trying to conjugate everything, right? And don't be snarky. Yes, they have. One has 3 letters, one has 2. They're spelled. They're said differently. But what's the difference between the meanings? What does it mean by and? What does it mean by or? Both conjunctions. Carson.
Is it both? Like and is both, or is one or the other?
Okay, good. That's the key here. And means both. And we're talking about 2 things in these problems. So yes, both. And could refer to many things, like 3 or 4 things, but we're just talking about both. And same thing with or. Or refers to either. And I was telling the other class, this lesson really hinges on these two definitions, and if you know what they are, you'll do well in this lesson and the next lesson, which is, it gets a little bit tougher with that. But when I look at these 2 words, I need to come up with questions to see if you can answer them correctly. All right, I'm going to ask you a few questions, and they're going to be yes or no answers. Okay, so what are your possible answers? Yes or no. All right, the first 2 are going to use the word and. Okay? So here is the question. My first question, it's a yes or no answer. Is Mr. A teacher and a student?
Or. Yes.
Either or.
Yes or no?
You said yes or no.
Yes.
No.
Okay, is Mr. A student and a teacher?
Yes.
And the answer is yes. I'm a teacher. I teach you guys. And if you don't know, I'm taking classes that actually starts. My next one starts tomorrow. So I'm both a teacher and a student. I'm both of them, right? And am I both of them tomorrow specifically at the same time? Am I a teacher and a student at the same time? I am. So that answer would be yes. He's and or. Is Mr. A, and don't be too goofy about this, but is Mr. A male and a teacher? Is that yes or no? Is he a male and a teacher? Yes, he's both. He's both a male and a teacher. So you would say yes. Do you guys understand how to use the word and on a yes or no statement? Let me give you another one. Is Mr. A an English teacher and a math teacher? Yeah. If you put it that way, I can kind of say, but is he an official English teacher and math teacher? And the answer is no. Am I a math teacher? Yeah. But am I also an English teacher? No. So that answer to am I a math teacher and an English teacher is no. I'm not both of them at the same time. Do you guys kind of understand what and means then? And how to answer yes or no with that? Okay, let's go with the or. It's a little bit tougher. Your answers to these questions are going to be yes or no. It's one or the other. Okay, and some of you might appreciate this. Is Mr. A Warriors fan or a Cavs fan? Yes or no?
Neither. I mean, both.
No.
See, this is where it gets tough. The answer is yes. He is a Warriors fan or a Cavs fan. Isn't he one or the other? It's either. So the answer is yes. Here's one for appropriate for last night. Is Mr. A an Alabama fan or a Georgia fan? Yes or no? What do you think? No, I'm neither fan. I don't go for either one of them. So the answer to that, is Mr. A an Alabama fan or a Georgia fan? The answer would be no. He's neither of them. So you see how the word or and the word and have slightly different meanings on a yes or no question. You guys kind of get that? Okay. Here's another one. It's kind of silly, but follow me. Last one for the or. Is Mr. A male or a female?
Yep.
Yeah, he's either a male or a female. Yes, he's a male. So it fits. It's not saying you have to be both, which is impossible, but you're saying or. Do you guys get and or? Because I'm going to ask this again and again and again in this lesson. All right. We're starting with and we're going to look at page 406. And the reason we call this lesson solving compound inequalities is because we're going to deal with two inequalities in one problem. Okay, so two of them in one problem, linked up by the word and or the word or. Okay, so example number 2 on page 406 is the first one we're going to start with. And it says graph the solution set of x is greater than or equal to negative 2 and x is less than 5. This is example 2. All right. What word are we combining these two individual inequalities with? What word is it? The word and. So my answer has to fit this inequality and that inequality. So this is how we're going to start off. Can you guys graph this inequality right underneath? How would you graph that? What kind of circle goes on negative 2? Closed circle. So we're just going to put a closed circle there. What kind of line, or where does the line go? Left or right? Sorry, here. On x is greater than or equal to negative 2. It's greater than. It goes to the right. Okay, so that's the first inequality. And this is review. Hopefully you know how to do this. How would you graph the second inequality? So what kind of circle goes on positive 5? Open, with a line going to the left. Good, so a line going to the left. All right, so those are my two individual inequalities. But what I'm asking for is this. So once you're done writing that, please look up because hopefully you can see it. I'm asking for the value of x, and x has to be two things. It has to be greater than or equal to negative 2 and less than 5. So can anyone give me a number that is greater than or equal to negative 2 and also less than 5? Can anyone give me an example of a number? Emery? Is negative 1 greater than or equal to negative 2? Yes. Is it also less than 5? So negative 1 works. Another one. Claire? 4. Is 4 greater than or equal to negative 2? Yep. Is it also less than 5? So that works. I want somebody to tell me all the numbers. Show me all the numbers. Or tell me all the numbers. Your choice. Really, a lot of takers on this. Nate?
-2, -1, 0, 1, 2, 3, 4.
Good. You gave me some good numbers, but I want them all.
Oh my gosh, they're
Yeah, they're... Oh, man. Who's cruel enough to do that? All right. Some of you kind of get what's going on. Carson, do you know?
-2, 3, and 4.
You're getting there. A little bit more. Go ahead. All of them. I want them all. List them all out.
1, 1, 0, 1, 2, 3, 4.
Those are the integers. I want all the numbers. I want the decimals, the fractions, all of them.
Oh, okay. -2.0.
Keep going. Yep. This might be a while, guys. No.
Wait,
It's
that wouldn't work actually because that would be greater than -2. Sorry, -1.
okay. Yeah, this is gonna be kind of tough, but I'm gonna show it to you right now. We're gonna combine these two inequalities into one big inequality. This is how you're gonna do it. You're gonna start with the smallest number, which is -2, and go all the way to positive 5. So -2, -1, 0, 1, 2, 3, 4, and 5. All right, so that's my number line so far. And you're going to combine both of these into one. And do you see compound, guys? You realize compound means more than one, like a building up of 2. All right, what kind of circle goes on -2 again? Closed. What kind of circle goes on 5? Open. Now, I think someone said -1. That's true. And someone said 4. And some people are giving me some decimal numbers. How do I show all the numbers that are greater than or equal to -2 and also less than 5? It's a line. I'm doing that for emphasis to show you it's all those numbers, isn't it? So isn't it like some of you said -1, 0, 1, 2, 3, 4? But it's also all those decimals and fractions in between. This graph shows me all of them. So do you have to list them all out? No, I couldn't list them out, and even if you did it, I'd feel bad for you because you were not close. But can you draw it out? And the answer is, of course, we just did. All right, are you guys okay with that? You guys kind of see? Are all these numbers right here greater than or equal to -2 and less than 5? Are they both? The answer is yes. Do you see how those questions, yes, no? Okay. There's also a special way to write it in set builder notation. So we start off, x is any number such that, and this is a special way that we'll get more comfortable with as we keep practicing. All right, x is greater than or equal to -2, and it's less than 5. So this is how I'm going to write it. Well, this is how you could write it. X is greater than or equal to -2, and then I don't have space there. I'm going to write it down here. And x is less than 5. You guys agree that's an accurate statement? Is that accurate? Okay. That's one way to write it. But there's a way to combine those two inequalities into one without using the word and written out. So write that down here. Okay, I'm going to come up here. I'm going to rewrite it and then show you, so you don't have to rewrite this here. X is any number such that x is greater than or equal to -2 and x is less than 5. So that's one way to write that set builder. The other way is going to combine them both, and let's see if you guys can follow me. It starts out the same way. X is any number such that x is greater than or equal to -2. Is this telling me that x is greater than or equal to -2? Is this saying that?
Yep.
Yeah, Mr. A, why don't you switch it around? You'll see in just a moment. But do you guys see that this means that? They mean the same thing? So far, okay? All right. X is greater than or equal to -2 and less than 5. And that's your compound inequality. That's how you write it. Okay? So let me show you again how I did that, just in case you didn't follow it the first time. So, is this saying, this inequality, is it saying that x is greater than or equal to -2? Is it saying that right here? It is also saying that x is less than 5. So is it putting those two together into one? Yes. A couple things I want you to notice. Your number line, remember the smallest number was -2 and the biggest number was 5. That's usually how it arranges right here. -2, then 5. Both inequalities are pointing the same direction. If you have a compound inequality where they're like facing opposite directions, it's probably not right. So make sure smallest, biggest inequalities point the same way. You'll be fine. You guys okay with that? All right. Let's see you guys try it out on page 410, number 12. I want to see if you guys can work that one out. I want you to graph your inequality and then write it in set builder. So do set builder second, graphing it first. So number 12 on page 410. All right, so here we have two inequalities, and your first step, solve both inequalities. So how would I solve this first one? What do I have to do to both sides? Yeah, subtract 6 from both sides. You're going to be left with -4 is less than or equal to y. And how do I solve the second one? Look at that. Subtract 6 from both sides. And you're left with y is less than 2. All right, on your graph, I need you to show me all the numbers that are greater than or equal to -4 and less than 2. So I start my graph. I put the smallest number on the far left, -4, and then I go all the way to +2. Okay, so that's the start of my graph. What kind of circle should go on -4? Closed. So I'll put a closed circle here because it has an equal to. What kind of circle should go on +2? Open. And then how do I demonstrate or show all the numbers that are greater than or equal to -4 and less than 2 at the same time? Shade in the number line in between those 2 points. All those numbers are greater than or equal to -4 and less than 2. You guys see that? How many of you are pretty good on this? Like, okay, I got that. 3, 4, 5, 6 of you, 7 of you, 8. Okay, there you go. More of you. All right. Who can write it in Set Builder using one inequality, one compound inequality? So let me start you off, and then I'll get some input. Y is any number such that y is blah and blah. Okay, Nate. Mm-hmm.
Why is any number such that -4 is greater than or equal to x is less than y less than 2?
Okay. Okay, and I think you said it right, or excuse me, you told me what it was, right? This is how I read it. So everyone who's kind of like, how do you even say that? You start off with the letter in the middle, or you start with the phrase in the middle, in between the two inequalities, so that's y, and you read it this way. Y is greater than or equal to -4 and less than 2. Can you guys do that with me here? Okay, ready? Y is greater than or equal to -4 and less than 2. Almost everyone I looked at was not doing it. Can we try it out? Can we ready? Y is greater than or equal to -4 and less than 2. Most people were doing it. All right. That helps you to be able to read it when you have it as a problem, and then hopefully that also helps you to like split it up. This is your compound inequality in Set Builder, and here it is graphed out. Okay? You guys okay with that? All right, we'll move on to the next one since it looks like. Are you guys doing okay? I asked that because I'm starting to get worried. Like, I see a lot of gloomy faces. Are you guys doing okay? Doing okay? Yeah, maybe. Are you guys sad it's Tuesday?
It's like Monday.
It's like Monday, but not. That's the cool part.
No, because you don't have PE.
Oh,
Yeah, so we're all tired.
Except
Gotcha.
it was a good day. It was gym. I think that's cool.
Oh,
I mean, I
don't
like
say that in
math.
front of me, please.
I like math. But I'd rather have PE.
Gotcha. I gotcha. Okay, yeah, so it's different, right? And today, it took me a while to get used to, wait, today is Tuesday. And Tuesdays are a little bit longer for me, but I'll get used to it too. All right, let's go to example number 3 on page 407. I care about your emotions, I guess is what I'm trying to say, because if you guys seem sad, then I want to see if maybe we can fix that. But that can't always be fixed, because I can't always give you more problems, right? That'll help sadness in a heartbeat. Okay, example number 3. Ooh. I'm going to read it, and then I'll write it up there. So if you're looking at example 3, this is how you read that. Solve x plus 3 is greater than -1 and less than 5. I'll read it one more time. X plus 3 is greater than -1 and less than 5. Yeah, and really what we're doing in this example is we're going from the compound inequality into its individual inequalities. Okay, so here we go. Okay, ready? I want to break this down into its 2 separate inequalities with the word and in between. And maybe looking at it thinking, what do you even do with that? Okay, this is the procedure, and I'll give you the reason why. Okay, what you do is you cover the second inequality symbol and whatever comes after it. Covering that up. How would you read that, somebody? Just read that for me, Jack.
X plus 3 is greater than -1.
Okay, so good. You can you're reading it that right to left, which is fine. I'm just going to write it like this, though, just so I'm not confusing one. That's all I did. I took out that second inequality and everything after it, and that's my first inequality. All right, to get the second one, I'm going to block the first inequality and anything before it. So can someone read what that is up there? X plus 3 is less than 5. So X plus 3 is less than 5. Now, the reason that is the case is because, remember, the way to read this would be x plus 3 is greater than negative 1. So don't you see x plus 3 is greater than negative 1 right here? And x plus 3 is less than 5. So, and x plus 3 is less than 5 is right there. All right, solve both inequalities. Get x by itself on both of them. Okay, I'll do it. Negative 3 on both sides. You get negative 4 is less than x. And you solve by subtracting 3 from both sides. You get x is less than 2. And what numbers fit x is greater than negative 4 and x is less than 2? So what numbers are greater than negative 4 and less than 2? An infinite set of numbers. Can I show you them? Yeah, I can't list them out, but I can show you. All right, so here I'll start with the negative 4, the smallest number, and I want to go all the way to positive 2. So does this look similar to anything that we just did, maybe? Okay. What kind of circle goes on negative 4?
Open.
Open circle. What kind of circle goes on positive 2? Open. How do I show all the numbers that are greater than negative 4 and at the same time less than 2? Yeah, shade in all this right here. And I'm doing it for like emphasis. It's all those numbers in between. All those integers and rational and technically real numbers. All right, that's my inequality. Can somebody write this, or can somebody tell me the set builder notation for that? I'll start it off. X is any number such that. All right, can someone give it to me? I see that hand. Turner. You know how to do it?
X is any number such that negative 4 is less than x and x is less than 2.
Okay. Now, Turner, when I called on you, you're probably thinking, why did he call me? I don't know if I know it. Did you know it? You just showed it to me, and she got it right. X is, and this is how I read it. X is greater than negative 4 and less than 2. Do you see how I got that? X is greater than negative 4 and less than 2, and that's showing it right there. That's set builder. Bless you. How many of you kind of get that? Maybe more, a little bit? Okay, so far so good? Okay. What word have we been dealing with this whole time? And. Okay. No, not yet. Don't worry, not yet. Let me give you another one to see if you really get this. Page 411. Okay, does anyone have a question how I went on example 3 from this compound inequality into its individual inequalities? Does anyone have a question on that? Yes, ma'am.
Do you have to turn it into inequality?
You don't have to, technically, no. But you should think of it like that. That's what you're thinking of when you solve for that one. All right, any other questions? All right. I think you guys can do this. I think you're capable. Ready? On page 411, number 51. Oh, man. That's a high number, Mr. A. Wait, is that our homework? I don't know. Might be. 51. All right, I'll work with some of you if you need it, but try it out at least. Let me read it for you, and I'll read it another way. Maybe it'll make more sense to you, but I'll read it our original way. You read what's in the middle between the two inequality signs. I read this: 2m minus 1 is less than m and greater than m minus 5. Or you could have read it like this: m is greater than 2m minus 1, which is greater than m minus 5. You see how this is greater than that? You guys see that right here? And this is greater than that. So I'm just showing you like a progression. All right. If you say it one way or the other, it's fine. But how do I break it down into its two inequalities? Does that anyone remember? Anyone know the first inequality? What do you do with the second inequality symbol and anything after? Block it out. So how would you write that? It says m is greater than 2m minus 1. m is greater than 2m minus 1. That's your first inequality. And what's your second inequality? Claire?
-1 is greater than m.
Super close. It's you block that first inequality and anything before it, and it's 2m minus 1. Ooh. 2m minus 1 is greater than m minus 5. You guys see it? So you always keep this whole thing with the first inequality and the second one. Okay, can you solve those inequalities? These are multi-step inequalities, and a couple ways to do it. Get m by itself. And you're like, I can't get it. It's on both sides. Yeah, you can. Subtract 2m, for example. That's one way of doing it from both sides. And you get negative m is greater than negative 1. Was that what I wanted? Did I want negative m?
You want 1?
So m is less than 1. Oh, how in the world did I get that? How did I go from negative m is greater than negative 1 to m is less than 1? What did I do from this step to this step? What did I multiply or divide both sides by? Negative 1, so I have to change the direction. This is my inequality. All right. And, all right, how do I solve for this one? In a similar way, if you want to get m to one side, you could subtract m from both sides. And you're left with m minus 1 is greater than negative 5. Then you add 1 to both sides, and you're left with m is greater than negative 4. All right, here are my two inequalities. So do you guys remember how to solve for both inequalities? This is a multi-step. That was Friday's lesson. Okay, but how in the world do I graph this? Can someone help me out with that? Actually, what I'm going to do is this. I'm going to write it here. Is less than 1 and m is greater than negative 4. Yay? Nay? Is it just greater than? Okay. Not equal to. All right, how do you graph that then? Somebody help me out. Yes, Maggie, I see that hand. Maybe.
I think it's going to be easier if you flip it. So negative 4 is less than m, and then you can just put negative 4 on the number line all the way to the line.
Okay, I'll do that. Okay.
And then you have open circles on negative 4 and 1.
All right.
And then darken the line direction.
Hold on. Before we go further, are you saying that any one of these numbers would fit both of those inequalities? Yeah, that's what we're saying, okay? That's a compound inequality, and it fits the word and. All right, so that's my graph. Somebody else give me my set builder. Yes, Matt. Thank you for your participation.
M is any number that m is less than 1 and m is greater than negative 1.
Okay, like, did you write it flipped? Okay, this is one way of writing it. Notice he said it differently, but this is another way of writing it. This is how he did it, hopefully. You put m is less than 1. Oops, that's not 1. M is less than 1, and okay, both of these are saying the same thing. The reason I go with this route is because this reflects this graph like right away. Do you guys see negative 4 is the first number, 1 is the second number? So m is greater than negative 4 and less than 1, okay? But isn't m, can you also say m is, oh, see, this is where I get confused. Less than. So you did it like that, Matt, sorry. Isn't m less than 1 and greater than negative 4? So you could say it that way, but I like doing it this way because it reflects this graph right away. Like it's almost a perfect reflection, although that's not wrong. That's not wrong. Okay. How many of you got that? How many of you got that? How many of you got that?
Sure.
Okay. Any questions on that so far? Okay, I'm going to pause this video. Or actually, I'm going to